Oh, now see, I was talking for like a minute and a half, and they didn't turn the cameras on. So, so back to what we were doing.
There they are. Where have you been?
Where have you been? So here's the deal. We need to work with the execution policy. Now, I just want you to take a quick look at this slide because it lists the execution policy for us kind of quick. Now, we have a couple of commandlets that'll let us work with the execution policy, and by default, you are restricted. In other words, no scripty allowed to run. Now,
interactive only.
Yeah, and I just want to point out that, see the word under here called unrestricted? Can we just right now kind of put into our heads that that's not an option for you to set?
It did it with bypass. Bypass. Consider bypass like...
Yeah, unrestricted and bypass. So can you kind of, I don't want you drawing on your computers, but can you just kind of cross those off? Restricted, unrestricted. Well, restricted's good for, but no, cross off unrestricted, bypass. Can we focus on the two that we really want you to focus on, which is remote signed and all signed? So do you want to talk about what is this signed thing in the first place that we're talking about?
So basically digital signatures. Now in the past, like VB Script had this, that was really bad stuff. All it did was said, hey, if a script is digitally signed, I'll run it. Not digitally signed by someone I trust. Yeah, so we took a different approach. We said it has to be digitally signed and you have to trust them.
So before we talk about the difference between all signed and remote signed, can you show us what it's like to sign a script?
Yeah, okay, so let me first go, I've created a self-signed certificate, and if you ever wonder about that, you just say new self-signed certificate. You can go create your own. I've already created some, and what I do is they're in the cert drive. Now, I don't know if we've talked about this, there are these things called providers, get PS drive. Okay, and you'll see the traditional drives like the C drive that we've been showing, but there's a certificate drive. Oh, so what I can do is I can do a dir of the certificate drive, and I do tab completion here, sorry, current user, and what I'm doing is I'm looking for a code signing cert. So the interesting thing is when I'm in the certificate drive, I can do things like, well, I can do recurse on any drive, of course, but I can say, give me the code signing certs. Oh, how strange. And then what I'm going to do is I'm going to say OV or output variable A. Okay, so what that did was it got me, did a recursive search, found me my code signing certs. I now put them in $A, and then what I'm going to say is $cert equals $A is 0. So now I've got a particular code signing cert. Okay, so now let's see. Let me get my execution policy. Get execution policy, and you see it's remote signed. Here, I'm going to change that to set execution policy equals all signed. Okay, oops, sorry. Oh. Equals, what am I doing? I'm being an idiot. Set execution all signed. It says, yep, do it. Now, here I am, and I have this test script. Oh, let me just edit that test script. Go ahead. Let me just get rid of this because I already signed it. That's not right. Would you see that? Oh. Okay, so there's my test script, right? And I go and I run it, and it says, no, you can't do it because it's not digitally signed. Okay,
yeah, because you went to all signed, which means everything must be signed. We'll talk about remote signed in a second, but everything must be signed.
So now I say, well, I'd like to sign it because I trust this. First, don't sign stuff you haven't understood. Like sign it, sign it. It's, remember I said earlier, like I take my badge out, I put it on the table, and I say, I guarantee this is going to work. When you're digitally signing something, you're taking your badge out, you're putting it on the table and say, anything wrong, take my badge. Okay, so be careful. So you probably want to take a look at the script you're going to sign.
Probably, yeah.
I take a look at that and I said, I'm good at that. Yeah. So you want to set the authentication code signature of, I give my cert, my $cert, and the file path.
Yeah.
Okay, now notice, now when I do this, test.ps1, here I'll cat it, cat test. Oh. Look at that thing. Look at that thing.
Wow.
Yeah? So now, I mean, that is a big beast.
So now, if your script actually did something harmful, we know who you are, and we can hunt you down.
Yes, except it's a self-signing script.
Right.
So
yeah.
But yes, we can. Now, here's the deal. /test. Now, watch what happens. Just because it's signed doesn't mean I'll run it. Okay? So we'll say, hey, do you want to run this thing? And you can say, hey, never run it. Don't run it once. I'm going to say run it once. Okay?
Awesome.
Now, if I had said always run it, it would have then taken that certificate and said, I always trust stuff from this guy.
From this certificate.
Yeah, and then you can run it. Now here, you want to see something crazy?
Yeah.
Here, I told you we pay attention to the security stuff, right? I told you that. Okay, so now imagine I go and I say, okay, so we say, let's say, now just because it's signed, I can run it always. So I can say set execution policy, and I'll say remote signed. Okay, so fine. Now I can go and I can run this thing. It just runs. Okay,
it just runs.
But now, watch this. Now, again, what did I say? When I get a script from the internet, you don't want to just run it. You want to examine it. Okay, so imagine I do this thing, and I say, hey, let me look at this thing, and I see that, and I say, hey, you know what? That's safe. I'm just going to run it. Right? I mean, take a look. Does that look safe?
It's got a signature.
Yeah,
it looks, and the code
safe.
looks safe.
Yeah. Okay. Okay. But wait. What about if I do this?
Oh, that's not safe. That's not safe now.
Now let's save that.
That's kind of mean.
So let's make sure we do this. So now, again, you come here and you have this script.
Yeah. That's mean, man.
But you evaluate it.
Right. I'm evaluating it. It looks good at the top, right?
Yeah. But what if down here or somewhere in there is there?
Somebody. Yeah.
Well, let's run it. What do you think? Should I run it?
Yeah. Let's. No. Because you're going to run it. It's going to restart.
No, I checked it out. I read it. It looked fine. Look.
All right.
Look,
it looks fine.
It looks
fine. Okay, run it. I mean, it looks great. You know, what could possibly go wrong? Nobody would have stuck anything in.
So check this out.
Oh, look.
Executable code found in the signature block. So we're aware of this threat. We're aware that people, how they're going to evaluate things, they're going to look at things, and we're going to see the signature block. They're just going to say, yeah. And so we look for people sneaking in bad code, and so we protect you from that and say, no, we're not running that crap. And we even tell you where it is, line 93.
Oh, I just got saved from this horrible thing. No, that's totally awesome. So here's the deal.
Secure.
All signed versus remote signed. All signed means every script that you download and that you create locally needs to be signed. And just to let you know, and I'm going to type this on my screen, there is a help file about_signing that will basically take you through everything that Jeffrey just did to sign a script. But let's talk about something for a second. Remote signed. A lot of you right now, it's going to be easier for you to start off with remote signed. Here's what this means. Anything you download, like from the internet, needs to be signed. Do you guys know that we know what you download from the internet? Okay, I'm just saying. A bunch of guys just went, I got to delete this. No, there was, I can't remember when it was put in. Mark of the Web was put in so that things got tagged if they got downloaded from the internet. This is to protect you. This is a feature, and they tagged it so that it overwrote rootkits. Well, PowerShell knows this, and PowerShell knows that if you downloaded it from the internet, if you're set to remote signed, there needs to be a signature on there. But if you make the script locally, there doesn't have to be a signature on it. So a lot of folks will set their policy, and this is okay to start with, to remote sign, just because it's easier to get started with, which that's fine, but as soon as you possibly can, you really want to go to all signed, because I want you to think about this. At some point, you're going to want to have this execution policy where you can run scripts in other places. And it'd be nice to be able to control this through that the scripts have to be signed. Imagine what your users might do if they figure out how to turn on scripting policy. They might want to download a script. If you set this through a group policy, then you're going to be able to help control what could be some possible issues of users trying to do weird things. So this is actually really important. Remote signed is good to start with. All signed is really the best to get to. Watch what happens now, and you've seen it with Jeffrey. Now that I have an execution policy that works, I can try to run my script, and I forgot what my script was. I love UPS1, and lo and behold, there it goes. Now, so script execution policy, need to turn it on.
Yeah, no, can I talk about the latest version? Latest version of Windows.
Top secret.
Top secret. We're disclosing. We're going to bring you into the circle of trust.
The circle of trust. I like that.
So the next version of Windows Server, let's say Windows Server 2012 R2, we changed the default execution policy to be remote signed by default.
Which is awesome, because that way you don't have to run around to your servers or issue out a group policy to get this, because you need your servers to have an execution policy. So when modules load and you want to load scripts from them, all that kind of stuff, it makes life a lot easier. So Server 2012 R2, right, is when it ships, will have the new policy, which is amazing to have that set.
Yeah, by the way, a number of people, let me just clarify one thing. We're not going to get into the details of the security, but I will just point out that even if you have like execution policy to be, unrestricted, whatever, an interactive user, basically an interactive user can do anything. Right. And they can bypass that. Don't worry about that. That is not a security violation. That's not a hole. There's actually a long explanation for that. We won't get into it here because it's not that interesting. But just don't freak out. If somebody has access to a terminal, I mean, basically, here's the thought. If they have access to a terminal, they can create programs, compile those programs, and run it, which means they can do anything. So at this point, it's just not a security
issue.
the
old thing of physical access, right? Physical access. So, guys, we want to do a couple of things to set us up for some scripting. One of the things that we want to do here, we're going to start doing, first of all, variables. Now, we've already been using them, believe it or not. Yeah, I just want to show you that, watch, I'm going to show you, there's a whole bunch of commandlets. So I'm thinking to myself, how would I find if PowerShell had any commandlets to help me with variables? I can do this, variable, and oh, looky, there's a whole bunch of clear variable, get variable, new variable, remove variable, stop looking at the screen. We're not going to use any of them. We don't need to. PowerShell makes working with variables really easy. We don't necessarily need these commandlets. So let me show you how easy it is to make a variable. Watch, variables have a $sign, and there's a lot of reasons for the use of this $sign. We're not going to get a chance to go into how the parsing engine reads all of this, but this is not the name or part of the name of the variable. It tells PowerShell, hey, something's about to happen, and if it's alphanumeric after it, my var, this is going to be a variable. And if you want to set this variable equal to something, equals, hello. Thank you. No commandlets required. I just created a variable. Totally awesome. You want to see what's inside of a variable? My var. But variables are awesomely cool, because variables don't just take text, they don't just take integers. Watch. My var equals get service bits. Guess what's in my var right now? Guess what's in my var? Wait a minute, let me show you. This is called my var. But wait, watch. Remember? Looky, look what's in my var. I got a service controller object in there. It's not just text, guys, it's service controller object. So I want you to notice something. We haven't talked much about running methods, but all these properties, and look, there's a couple of methods here. There's a start and a stop method. I have an idea. I wonder if I could use this dot notation that you started using. My var dot, well, let's see, a property status. Oh, it's running, and I wonder if I could get it to run a method like stop. Ooh. Now, I know you're all saying, well, prove it. All right. Well, one little thing is I'm going to do my var status, but you're going to say, oh, I see, it didn't work. No. If we refreshed everything that existed in Windows constantly, oh my God. So there's a method to help us refresh this. So refresh. And now look at the status. Boom. Totally awesome. VARs make your life much easier. And of course with scripting, VARs become very important. Now, there's a lot to do with VARs, and there's a lot of tips and tricks with working with VARs.
Can I just tell them one thing?
Oh, absolutely.
Yeah. So stop to mind. So here's the thing. I think it's because it's a jump start and it's tutorial. Like, why do we have this $sign? Some people are like, I hate $sign, blah, blah, blah. Well, here's why. So when we say $myvar equals get service bits, okay, right? Just works, right? But what happens if I do this, right? Some people are like, I don't like $signs. Okay, fine, what happens? And the answer is an error, but look at the error. The term myvar is not recognized as the name of a commandlet, okay? So when you start a command, when you start a line with a name, the question is, well, is it a variable or is it a commandlet?
Right.
And we have to know. And so that's why we have $signs in front of our variables, because you have to know. And this, remember I talked about the struggle between interactive programming and systems programming. This was the key thing, that interactive commands require a special syntax. In programs, you're not running things out of the file system. Right? You're running APIs and such. In an interactive shell, you run things out of the command. So when you type ping, you just want ping to work. You don't want to have to say, oh, well, I want to do something special for ping. So that's why you just type ping, right? But if you want $ping to be X, you type $ping. That's why we have the $sign. That's it.
No, and that's actually very important. Everybody's always asking about the $sign. So when you're working with VARs, you got to have the $sign. Now, a couple of little things. A little, let's play with, since we're getting ready for scripting, we're going to take this concept of using a VAR and try something here. Let's watch this. Let's see. There's a commandlet called read host. It'll actually read things from the host. The host. So let me see. $var equals read host. So whatever we read in is going to get stored in the variable. And I'm going to say enter a computer name. Now, guys, you can imagine this in a script already, because watch what happens. I'm going to strike enter, comes up and says enter a computer name. Okay, I'll enter one. Now, what's stored in var right now is that computer name. You can now use that variable, which is where we're going with all this, get service name bits dash computer name $var. Guess where we're going to go get that information from now? So we're going out to the DC in this case. So we're storing stuff in the VARs, and then we're going to use those VARs in our commands with our parameters as part of the arguments. This is going to start us making better scripts and being able to do automation a little bit better. But I want to show you just a couple of quick things, because you're going to hear this and you're going to see this a lot, and I just have to throw it out because I want to ask about it. So $var, if I do this, it just prints it to the screen, but we actually have a commandlet that is designed to print things to the screen for you. Let's do write host real quick. You're going to see this a lot, write host $var, same result, except write host has things like foreground color red, background color green. Yay, you can play with the colors. Everybody just got really excited because now they can play with colors.
Yeah.
Stop playing with colors. We have ways for you to play with colors, and you probably have heard the phrase every time you use write host, God kills a puppy. So don't use write host. Now I want to be straight with you. There are times to use write host. It's just I want you to see what you're doing, and when you start scripting, this really starts to matter.
Yeah.
$var. Watch what I'm going to do. I'm going to pipe this to get member. You would expect a result at this point. Look at what I'm getting. I get no object has been specified. In other words, nothing went across the pipeline. Write host just destroyed everything that I've been working so hard for with objects. Write host has annihilated it.
By the way, notice it showed DC on the host.
Yeah, because it actually wrote it out to the host,
yes,
but there was nothing going down the pipeline. And the point is, we want stuff going down the pipeline. So with write host, we have a commandlet that, watch this, write output $var. And it does the exact same thing, but it's doing it through the pipeline. Look, get member, look at what I got. I got a real object that's crossing across there now. Ta-da! So it matters. But everybody says, well, you lost the ability to make colors. Get over the color thing. We don't. Here's the deal. We have ways for you to make colors properly. You've noticed that PowerShell has a built-in color scheme that it uses. And as you start to script, this is going to become real paramount. As admins, we get used to certain colors popping up. So in PowerShell, we've included commandlets to use the existing color scheme. If you just play along, it'll all be good, such as, I want to write a warning. Please don't do that. Look, it comes up as a PowerShell warning, the yellow on black. So it makes sense to my brain because I've seen those warnings before, or things that I need to care about. I didn't have to go through and use WriteHost and come up with my own color scheme. And of course, we give you things like write error. And there's other stuff that we have, but write error being one. Stop touching me. And now it looks like a PowerShell error message, and I've generated the error, and it's in the same color scheme in the same format. So you don't need WriteHost most of the time. If you want to put something on the screen in a different color, great, but try to stick with write output and the other write commands that we give you to write things out to the screen, especially when you're working with your vars, because WriteHost can be somewhat problematic. You know, I'm checking.
By the way, this is very analogous to what I mentioned about the console. Remember I said I'm trying to kill off the console because I'm trying to kill off console apps, because apps that write directly to the console can't be automated. They are the enemy of automation. WriteHost is another flavor of a console app.
Is another flavor of a console app.
So don't do it. By the way, there are times we have a special, like, dispensation for people who are trying to do this. Here's the key thing. Say you wanted to write a script that was well formatted and had colors and all that good stuff, that's fine. But you use the word show. Okay? Whenever you see the word show, you should hear in your head, I'm not going to be able to program or script the output of that. So that's perfectly fine, but just make sure you use the right term, show.
Right. And yes, and most of the time, just don't use WriteHost. Okay, just don't do it.
It's because you like dogs.
It's because I like dogs, and I have to give Don Jones credit for that phrase, who uses that all the time. So let's do something kind of fun and kind of exciting at this point. I think that
You didn't show them the squiggle brackets.
Huh?
The squiggle brackets.
You want to show them the variables with the squiggle brackets?
Yeah.
Really?
That's awesome. Here, I'll do it.
It scares me. Okay, you do it.
So here's the thing. Hey, what can I do? Like, hey, is this an Anglo-centric English thing?
Okay.
And the answer is no, my friends. Like, let's say you wanted to have, you can have variables of any sort of names, including spaces, right? So you can say, hey, this is a test equals 4, right? And then this is a test. Woo, it's 4.
Woo!
Is that cool? Now, check this out. You can have anything you want in here, right? Oh, sorry, get the wrong thing. Oh, what the heck was that? Oh, that wasn't good. What did I do? Oh, good Lord, help me. I'm all confused.
Wait a minute,
No, I was just screwed up.
Yeah, there you go.
I just screwed up. Oh, here we go. There we go. There, that's what I meant to do. Okay?
There you go. That's
Equals.
sufficiently weird.
Wow. Whoa. Okay, so now, look, that's the name of my variable. Oh, did I screw that up? I did screw that up. Oh, no, I did equals. Okay, so that's the name of my variable. Is that crazy or what?
That's crazy.
But wait, here it gets a little bit cooler. Because we draw this distinction between the syntax of a variable and the semantics of the variable. So here, the syntax is just showing you it's a container. And I mentioned you can put any parameter you want. You can use any character you want. You can use Unicode, etc. It's not entirely true. There's a special character, and that is the colon character. So let me make sure. Here's where I am. Imagine I do this. Imagine I do 1.5, okay, and then I'm going to put that in a file, test.txt. Okay, so now imagine, watch this. C: jumpstart test.txt. Okay, so look at that. So I did $ my parameters, and I gave a file path, and I get the value of the file.
So you're basically saying, calling do this.
Well, it is, hey, this $ syntax basically says, where do I store my data? And in general, the way we think of variables is, well, you store data in memory somewhere, and when the process goes away, well, that goes away, right? Well, look here, look here, look here. Wait a second. So now I get a second command, and I can say $C : jump start / test test.txt. I did squiggle brackets. Oh, did I do that wrong? Oh, sorry, slash. I can get it there. No, wait. So equals. I go to this machine.
And now.
So now I've got variables that cross
That cross
machines.
between. That's awesome. That is totally awesome.
Fun.